Question 2, find the y dx if y is this, and b, we have the function. This aspect is derivative of integrals. This one, your dy dx is equal to d dx of your question. We're going to substitute for this one. We're going to change the variable. We're going to let u be equal to what? This. The u dx will be equal to exponential function. The derivative is the same, but times derivative of the what? Of the power, which is half x2 minus half. This will give you 1 over 2 root this times what? Times this is equal to. We're changing the variable, and that will be d du. Your upper limit is u, and then cos t over t dt times du dx. Then you now begin to substitute now. You substitute your upper the upper limits. Okay, for this lower limit, we'll not bother ourselves because derivative of 7 is 0. So we now have cos. Anywhere you see t, put the upper limit there. That's cos u over u times du dx. We have the value 1 over 2 root x times what? Times this. Then we can return the u back. So, and that's that on the derivative of the integral. For this b parts, what we are going to do, we're going to use logarithmic differentiation because this is a complicated function. Okay, when you have a complicated functions, you have a quotient functions. Okay, we apply logarithm differentiation. Take the length of both sides, take the natural logarithm of both sides, and that will be equal to. According to the rule of logarithm, this power will come to the front. You have this differentiator implicitly with respect to x. So we now have this one. This will be 1 over y, the y dx. I'm going to take the first one constants and differentiate the second one. So that will be 1 over derivative of ln. So that 1 over the function times the derivative of the composite function. So that will be, if you differentiate this one, d dx, this one, is going to give you ln of the base, and then times this, the function itself, and then times the derivative of the power, times 2x, and then plus this one, close the brackets, then plus. Can you keep this one constant? Then natural logarithm and differentiates the other function. So that's that on that. To buttress that, don't forget that if you have d dx of 3 to power x, it's going to give you this ln 3 itself times the length of that base. Okay, but in this case now we're having 3 to power x squared. So it's going to be ln the base, okay, and then times the function itself, and then times the derivative of this power 2x. In this case, the derivative of this power is 1. Okay, so that's that on that. Then the next case is to remove this y here. So multiply 2 by y. So we have the y dx equal to y. Open your big brackets. This one. So the final thing to do now is just to put in the y value. So that's that is on this question. Please quickly click on the watermarks on the video, subscribe, click on like button, and begin to type your comments. Finally, share the links of this video on other social media platforms. Thank you for doing that.